Welcome back to Computer Science and Engineering 120, Learning to Code. This is Module 11, Consuming Data Part 1. In this part, we'll give an introduction to Ajax, including an overview of the client-server model and the HTTP protocol. We'll talk about Ajax and in particular jQuery's Ajax function, and briefly discuss security and other concerns when using this functionality. Many applications follow a client-server model, where the client is responsible for end-user interaction and the server provides various services, such as data, persistence to a database, etc. This supports a separation of responsibility between the client and the server. The basic interaction between the client server is that the client makes requests and the server gives a response. For our purposes, the client will typically be a web browser, but it doesn't have to be. In fact, it doesn't even have to be intended for an end human user. It could be another program consuming the service offered by the server. Typically, the server is a web server. When dealing with the client-server model over the web, the de facto protocol for communication is the HTTP protocol, which stands for Hypertext Transfer Protocol. It's the most widely used protocol on the web. A protocol is simply a set of rules used for communication. Again, in our context, the client is a web browser and the server is a web server. Let's take a look at an example. Here we have the Chrome web browser. Chrome comes with a lot of really cool tools for developers that allow you to debug JavaScript and take a look at the internal workings of a web page. Let's go to a web page that contains some information on free computer science textbooks. When we do, a lot of requests for various resources are made. This is the main index file for the web page. Note we've got some headers, some content, and a response. This is how the web server actually responded with the source code of our HTML page. In addition, it responded with a bunch of metadata, including a status code 200 OK, and some other data here that gives some more information about the server. When the request was made, that it's text HTML, how big it is, etc. The request also provided some headers as well. For example, it's indicating that we're using a Mozilla-based web browser, in particular Chrome version 44. Subsequent calls were made for various resources, including JavaScript files, CSS files, and image files. When using HTTP, the two most common types of requests are GET and POST. Both submit the submission of parameters, that is, inputs to the request. And responses may include various status codes, as we already saw. 200 was to indicate a success. Other common ones include 403 for forbidden, 404 not found, and 500 internal server error. Responses also include response data. For example, if we requested something that did not exist, we would get back a 404 status, along with a bunch of header results. Our goal is to write a dynamic application. That is, we want to be able to use various web services in our application. For example, suppose that we wanted to utilize the functionality offered by Google Maps to compute a distance from one location to another. Or we wanted to integrate services offered by Yahoo Finance, which offers data on the latest stock quotes, exchange rates, etc. Another example is UNL's Bulletin, which offers data on all courses offered at UNL. Moreover, our own application can interact with our own server to get additional information. For example, loading student data or enrollment data, as we've seen before. The solution is to use Ajax in JavaScript through the XML HTTP request object. Ajax here stands for Asynchronous JavaScript in XML. This allows us to write JavaScript code that can be run in a browser to make additional requests to a remote server for data and then process the response. It's asynchronous in that each request and response requires network connections and data to be transferred over the network. This is done so in the background so that it doesn't freeze or block the rest of the application. The name involves XML, which stands for Extensible Markup Language, mostly due to legacy of how this was originally developed. However, you can deal with pretty much any type of data. We'll deal mostly with JSON data. Moreover, we'll focus on using jQuery's Ajax function instead of the XML HTTP request object, as it's much easier to use. It only takes one parameter. It's an object with the request's full configuration. Full documentation can be found here, But the essential elements that we'll use are the following 4 pieces of data. A URL, indicating the URL, the web address that we want to connect to. Data, which is a JSON object representing any parameters that you want to be sent as input to the server. Success, which is a callback function to be executed if the request is successful. If it is successful, then data is passed into this function to be processed by your code. You can also provide a callback as an error to be executed if the request fails for some reason. The default behavior is to use HTTP's GET functionality, but it can be changed using the post using method and providing a post string. As a demonstration, let's consider UNL's bulletin. Again, we have Chrome. Let's go ahead and cut and paste the URL for information regarding this course. Putting that in as a URL returns a regular web page that is intended for a human end user. However, if we provide inputs, in particular, requesting that the format not be an HTML page, but instead to be JSON data, it makes a different response. The response here is pure JSON data. The same data is being displayed, including the title of the course and the description, but it's being sent in a different format, in this case JSON. We would be able to integrate this with our application by processing this JSON and displaying, say, results. Some other considerations when doing this. If a user invokes an action that will load data asynchronously, it's best to give them some visual cue, for example, a loading graphic, so that they understand that a request is being processed, rather than just sitting there wondering what's happening in the background. Asynchronicity also needs to be considered. You cannot assume that a request will always succeed. Moreover, you can't always assume that a request is fast. You need to use the proper callback mechanisms to make sure that everything works. Again, for a good user experience, feedback needs to be communicated to the user. If the request ended up in a failure, that needs to be indicated to the user somehow. Or, if it's successful, then maybe you would replace the loading graphic with the results. In addition, requests to the same server can be made relative. For example, if our script was being served from example.com, and we wanted to make a request to a service that's being hosted at example.com/services/dataservice.php, the URL would only need to be /services/dataservice.php because it's relative to the same server that served the script. Finally, another consideration is that many open web services require the use of an API key, an application programmer interface key. This is because they want to identify the users or applications that are making requests to their servers, so that they can either limit or cut off access if you make too many requests, or so that they can charge money for their services. There are also security considerations. Most browsers will enforce what's called a same origin policy. For example, scripts from server A are not allowed to make requests to server B. Consider the following scenario of why this would be bad. Suppose that a criminal lures a user to a malicious server A, whose scripts then make requests to a bank server on server B. This is bad because it's coming from the same client. It will look like the request is coming from a legitimate user, but in fact the request is being generated by a script that's being hosted on a different server. The request does not have the same origin, so it's denied. Unfortunately, this can be very limiting. We do want to be able to use third-party services such as Google Maps or UNL's Bulletin. The workaround is that server B can set what's called a cross-origin resource sharing or CORS policy. This policy would allow it to accept requests even if they're not from the same origin. They're from a cross-origin. This is only recommended for truly non-sensitive public data, such as UNL's Bulletin. Another workaround is to use a proxy or proxy service. That is, a non-browser application that does not have the same origin policy. It can make a request from server A on our behalf and then relay the data back to us. We can choose to set a cross-origin resource sharing policy ourselves, or design our script and server such that the request is being made to the same origin.